Hello everyone. Today we would be learning about the properties of sodium metal. Sodium is an element of the alkali metal group, that is group 1 of the periodic table, because they have a single electron in its outermost shell. A little bit about the history. Sodium was discovered in 1807 by Sir Humphrey Davy by the electrolysis of sodium hydroxide. Sodium metal can never be found in free state in nature. It is always found in minerals like feldspar, sodalite, or rock salt, that is sodium chloride. Since sodium metal has a single electron in its outermost shell, it is highly reactive, and sodium metal on exposure to air will react with the oxygen and moisture present in them, forming the oxides of sodium and sodium hydroxide. Hence, it is always stored in mineral oil or kerosene, as you can see. Sodium metal, as any other alkali metal, is a silvery white and very soft metal which is highly reactive. Here you can see this is the sodium metal, which is silvery white in color, but you can see a bit of dullness here and there. That is because of the oxidation. Before learning about the chemical properties of sodium metal, first of all let us dry the sodium metal by using a filter paper or a paper towel to remove all the mineral oil. Sodium metal is like every other alkali metal, that is, it is very soft and you can easily cut through the metal, and the consistency is similar to a rubber piece. And on cutting you can see that the cut surfaces are very shiny, and soon those shiny surfaces will turn dull, that is because of the oxidation. You can see the cut surface now, it is very shiny and reflecting the light from my camera. Soon after cutting those pieces of sodium, you can observe vigorous reaction on them. That is because of the presence of high humidity in our atmosphere here. The next experiment is the classical experiment which everyone knows, that is the reaction of sodium metal with water. I am filling this dish with water now. Now I am adding phenolphthalein indicator. This indicator becomes pink in alkaline medium. On adding a piece of sodium metal into water, you can observe a very vigorous reaction. This reaction is highly exothermic, making that piece of sodium melt, and the color has turned pink. That is because this reaction produces sodium hydroxide and hydrogen gas, and sodium hydroxide is basic, which turned the phenolphthalein pink. Sodium metal reacted with concentrated sulfuric acid vigorously. That is because sodium is acting as a reducing agent, which converted sulfuric acid into sulfur dioxide, hydrogen sulfide, and sodium sulphide was formed. Now we see the reaction of sodium metal with sulfur powder. You can see that there is some sulfur powder which is yellow in color in the spatula. On heating, the sulfur powder first melt and then it catches fire and burns with a blue flame. Now we add a piece of sodium metal into the molten sulfur. The sodium immediately catches fire and reacts vigorously, forming sodium sulphide. This is a reaction of sodium in glycerol. Sodium reacted with glycerol, forming the sodium salt of glycerine, that is the sodium glycerate. This reaction is not very vigorous compared to the previous reactions you saw. There is formation of a white colored precipitate around the sodium metal. Now we see the reaction of sodium metal in methanol. Sodium reacts vigorously with methanol, forming sodium methoxide, and hydrogen gas is evolved. This reaction looks exactly similar to reaction of sodium with water, but instead of the hydroxide, here we are obtaining sodium methoxide. The reaction of sodium with chlorine gas. I have synthesized chlorine gas by mixing concentrated hydrochloric acid with potassium permanganate in that test tube. I have heated a piece of sodium metal until it melted in a spoon, and now I am introducing that spoon into the test tube containing chlorine gas. You can see that there is an immediate reaction and the sodium metal catches fire, and here there is a direct reaction between sodium metal and chlorine gas forming sodium chloride. Sodium reacts with bromine, which is an exothermic reaction, and it produces sodium bromide. This reaction is less vigorous than sodium reacting with chlorine. Now we see the reaction of sodium metal with iodine. For that purpose, we have to synthesize elemental iodine. Here I have taken 2 spatulas of potassium iodide crystals in a test tube, and now I am adding concentrated sulfuric acid. You can see that on adding the acid, there is a dark coloration in the test tube. That is due to the formation of iodine. Other byproducts like hydrogen sulphide is also formed on this reaction. Now I am heating a piece of sodium metal. The melting point of sodium is 98 degrees. On reaching about 290 degrees, there is auto ignition of sodium metal, which you just saw. On introducing the piece of sodium metal into iodine, there is a reaction taking place which is also exothermic, but the reaction is not as exothermic as with chlorine, and this reaction produces sodium iodide. Sodium metal reacted with heated mercury, forming sodium amalgam. This reaction is highly exothermic. And after this reaction, the end product formed is a solid chunk of sodium amalgam. The importance of sodium amalgam is in organic chemistry, and this alloy is used in liberation of hydrogen gas, which is less vigorous when compared to sodium in water. You can see that on adding the sodium amalgam, initially there was a vigorous reaction due to unreacted sodium which was covering the amalgam. Later you can see a steady reaction is going on and hydrogen gas is slowly liberated.